Hey guys, Long here, back to another math video. Today we're going to be doing 2010 AMC 12V problem 20. I like these type of problems because they don't actually require much content knowledge about mathematics. They actually just really require some critical thinking on your part. It really tests how creative you are in solving these problems. So try to look at this problem. Pause the video if you need to, and I will go on to the solution. So a geometric sequence AN has A1 equals sine of x, A2 equals cosine of x, A3 equals tangent x, for some real number x. What value of n does AN equals 1 plus cosine x? Okay. It's a geometric sequence, right? So, which means that each term has a common ratio between them. So, A2 over A1 is equal to A3 over A2. By the definition of geometric sequence, and that's because to make a geometric sequence, you just multiply each subsequent term by a common ratio, and this is the common ratio. So what is the common ratio? Well, obviously, A2 over A1 is cosine x over sine of x. That's equal to tangent of x over cosine of x. See what R. By definition of geometric sequence. So let's see what we can do with this actually. So we know we'll use this as the common ratio for forming subsequent terms, but maybe this equation can tell us something. That means cosine squared of x equals sine of x times tangent of x by cross multiplication is equal to sine of x times sine of x over cosine of x, because tangent of x is equal to that. Which is equal to sine squared of x over cosine x, which means cosine cubed of x equals sine squared of x, because we multiplied both sides by cosine of x. So we have this, which may be useful. Alright, let's try to form, see, the answer choices go up to 8, right? So let's try to form the next few terms up to 8. So A1 equals sine x, A2 equals cosine of x, A3 equals tangent of x, A4 equals what? A4 is equal to cosine of x over sine of x times tangent of x, which is equal to 1. Because tangent of x is sine of x over cosine of x, right? So that's equal to 1. So which means A5 is just equal to cosine of x over sine of x times 1, which is cosine of x over sine of x. A6 is cosine squared of x over sine squared of x. Oh, well, we can do something with this, because we know sine squared of x is equal to cosine cubed of x, so that's equal to cosine squared of x, cosine cubed of x, equal 1 over cosine of x. Okay. 7 is equal to, so cosine of x over sine x times 1 over cosine of x. That's equal to 1 over sine x. It's convenient. And A8 is equal to cosine of x over sine squared of x. None of them give us this, which is sort of inconvenient, which means we probably have to do some manipulation. So let's see what we can do, right? So we have 1 plus cosine of x. Is there any way we can sort of I don't know, change this into something we can use? Well, let's think about this. So here, so we know cosine cubed of x is equal to sine squared of x, right? And I should probably actually simplify this some more, because we have a sine squared of x. I forgot to do that. So we know that's true. So what if we just try multiplying this by cosine squared of x? Because cosine square root of x a n. Right, so now we have cosine square root of x plus cosine cubed of x equal cosine square root of x a n, whatever a n may be. Cosine cubed of x, since we just made that term, right, is equal to sine squared of x. So cosine squared of x plus sine squared of x cosine squared of x a n. This is a rule of trigonometry. Cosine squared of x plus sine squared of x is always equal to 1. So 1 equals cosine squared of x a n plus a n equals 1 over cosine squared of x. And which term is that? That seems to be this term. So a8 seems to be the term that is equal to 1 plus cosine of x. So the answer is E. So it's D. And E is still the same. And yeah, so that looks good.